Please subscribe my YouTube channel and press the bell icon on the YouTube app and never miss another updates from my YouTube channel. Hello friends, today I'm going to talking about Apache Kafka. So in this video I'm going to talk about what is Apache Kafka and what are the benefits of using like Apache Kafka, and so what is the key features of the Apache Kafka and how to integrate this Apache Kafka in the Spring Boot. What are the advantages and what are the disadvantages of using this Apache Kafka, I'm going to explain in this video. Okay, so first of all, like, what is Kafka? So Kafka is nothing but like it's a open source distributed event streaming platform. Okay, so Apache Kafka is a distributed data store, okay, optimized for like ingesting and processing streaming data in real time. So this is used by thousands of companies for a high performance data pipelines and streaming analytics and data integrations and mission critical applications. So here I mentioned like event streaming platform. So what is the event streaming basically? So event streaming is nothing but streaming the data is a data that is continuously, okay, generated by thousands of data sources. So event streaming is the practice of capturing the data in real time from event sources like databases, sensors, mobile devices, cloud services, and software applications in the form of streams of events. And what are the key features and advantages of Kafka? So the first one is high scalability. So Kafka is designed for like horizontal scalability. Okay, so horizontal scalability means like allowing it to handle massive amount of data by adding more hardware or like nodes to that cluster without any downtime. And high throughput and low latency. First of all, like, what is throughput? A throughput is a measure of how many units of information a system can process in a given amount of time. Okay, so whereas latency, what is the latency? Basically latency is nothing but like the delay in the network communication. So it shows that time that the data takes to the transfer across that network, right? So here high throughput means what? So high throughput means I mean like so it is capable of like handling like high velocity and high volumes of data. So Kafka can handle millions of messages per second. And low latency, what is a low latency here? So Kafka can store the data in a memory, so that will enabling quick read and write operations with low latency, because it will store the data in the memory, right? So that is the reason it will enable that quick and read and write operations with a low latency, so that can be deliver this high volumes of messages using a clusters of machines with the latencies as low as 2 milliseconds max. Okay, and after that we have like distributed systems. What are the distributed systems here? So Kafka is distributed architecture, so that will ensure that fault tolerance and reliability. So data is distributed across multiple nodes, okay, that will reducing the risk of the data loss. And we have a publish and subscribe messaging system. Okay, so it operates as a publish subscribe system, so where producer can publish the messages, publish the messages or data to the topics, and consumer subscribes to those topics to receive the data. Okay, so and this is publish and subscribe messaging system. Whereas like retention and durability, so what is the retention and durability here? So if we're talking about the retention durability, Kafka offers configurable retention periods of messages, so that will ensuring the data durability over the time here. So data can be stored for a specified duration or like size, so that will allow for like if you want to replay or like reprocessing your data, so this retention and durability will come into the picture. Okay, so I mean like you can safely securely store the streams of data in a distributed and durable and reliable and fault tolerant cluster. So support for stream processing here. So what is a stream processing here? So basically it provides a streaming platform for a building real-time streaming data pipelines and applications. Okay, so Kafka Streams API enables streaming processing, so within the Kafka ecosystem itself. And we have a connectivity and integrations. So Kafka supports like connectors that facilitate the integration with the various data sources and sinks. Okay, so that will allow the seamless data transfer between like couple of systems. And what are the Kafka key concepts here? So the first one is producers. consumers, consumer group, topics, partitions offset, brokers, leader, follower, replications, Kafka clusters. Okay, so these are the Kafka key concepts. So you should know. So before you're going to implement any Spring Boot with like Kafka application, right? So you should know these key concepts here. So first of all, like what is the producers here? So the producers is nothing but the producers send the streams of data to the topics in the Kafka clusters. So here we have a producer. This producer would send the messages to this topics. I mean like streams of data to this topics in the Kafka cluster. So this topic available inside this Apache Kafka ecosystem. This Apache Kafka ecosystem will have a Kafka cluster. So this Kafka cluster will contains more than one broker. Okay, this broker will contains this topic. Okay, so this topic will store the streams of data. So this is how this producer will make use this topic, okay, to send the streams of data to this topic. And we have a consumers on the topics. What is the consumers here? The consumers subscribe to those topics and read the data from the partition. So here we have a couple of producers. This producer will send the message to this um, topics here, right? So here we have a consumers. So the consumers subscribe to these topics and read the data from the partitions, right? So what is the topics here? So topics will store the data, right? So basically, so data is organized and stored in Kafka topics, right? So which is act as a logical channel for the message here. So this is consumers and topics. The next one is consumer group here. So what is a consumer group? So if you're talking about the consumer group, so the consumer group will contains more than one consumer, right? So consumers are organized into consumer groups here. So where each group read from a topic. So here we have a one consumer group. This consumer group is reading the data from one topic here. And what is Kafka partitions here? Okay, so partitions, each topic is split into couple of partitions. Here we have like topic ones which is split into the multiple partitions here, that is partition 0 and partition 1, right? So where the basic unit of parallelism and distribution in the Kafka. So here the messages with the partitions are ordered and assigned an offset for tracking here. So here we have consumer group 1 and consumer group 2. These are two consumer groups are parallelly consuming the data from this partitions here. And we have a Kafka partitions, right? So as I mentioned earlier, so each partitions within a topic consumed by only one consumer within a group here. So why? So basically this will improve the performance of the system. So that will allow like for parallel processing here. So if you observe here, so we have a consumer group 1 and consumer group 2 here, right? So each consumer group has two consumers, right? So each consumer, okay, consume by only each consumer. So here consumed by only one partition, right? Not multiple partitions. That is not allowable here. Okay, so I'm going to discuss about consumer behavior with the partitions here. So what if like if we are having like single consumers or like multiple partitions, or like if you are having like multiple consumers with multiple partitions, how the consumer will behave here with the partitions. Okay, so that's what I'm going to discuss here. So suppose let's say that I have a single consumer here. Okay, now this topic has a 4 partitions. This consumer group has like only one consumer. Okay, so now so all the partitions, okay, so this consumer will consumed by all these partitions. Okay, all 4 partitions can be consumed by the single consumer here. So what if this consumer group has like more than one consumer, right? So now if 2 consumers are present, then these 2 consumers will consume 2 of the partitions from this topic, each consumer. So that is like Kafka will be auto balance and assign 2 partitions to each consumer for load distributions here. Okay, partition 0 and partition 2 will be consumed by this consumer 1, whereas partition 1 and partition 3 will be consumed by this consumer group, consumer 2 here. And now so this topic has a 4 partitions and this consumer group also having 4 consumers here, right? So both are identical here, right? So each consumer consumes the data from one partition, so that will ensure the balanced consumption here. So here we have 5 consumers in the consumer group, whereas we have a 4 partitions. So that means like we have a one more extra consumer. Okay, so in this case all the partitions, okay, will be consumed, sorry, all the consumers will be consumed by this all the four partitions here, and the remaining consumer will sit idle here. Okay, so that means like each partition can only be consumed by one consumer at a time here. Okay, and this scenario actually having like more than one consumer group. So the first consumer group has having like four consumers, whereas like a second consumer group has like two consumers. So the first consumer group, all the four consumers will consume the all the four partitions here, and whereas like consumer group 2 has like two consumers, right? The first consumer will consume the two partitions, whereas second consumer from the consumer group 2 will consuming another two partitions. Okay, so this is how the consumer behavior will be look like with the partitions. And we have like Kafka partitions offsets. So in Apache Kafka, so basically a offset is a unique identifier that represents the position of a consumer basically within the particular partition of a topic. Okay, so why basically offsets are coming to the picture? So offsets are like crucial for consumers to keep the tracks of their positions in the topic partitions. So consumers uses these offsets to know which message they have to already consume and which ones they need to consume the next. Okay, so for example initialization. So when a consumer group is initialized, okay, or a new consumer joins in a group, so it needs to know so where to start the consuming the messages from. Okay, and so this is when the offset comes to the play, right? So this consumer group coordinator assign the each consumer with the group so a partition to consume from and initial offset to start consuming from. So here we have one topic. So this topic has multiple partitions, right? So partition 0, partition 1, partition 2, and partition 3. So here we have like each partition has like offsets, right, in incremental order. So this is how the messages will write this on like partition offsets, and the consumer consuming the message by using this offsets, right? So as a consumer reads the message from the partition, it keeps tracks of the offset of the last message it consumed. Okay, so this offset is the periodically committed back to the Kafka as well. So by doing this, if consumer crashes or like needs to be restarted, it can resume consuming from where it left off, okay, by starting from the last committed offset. And so brokers and replications. What is a broker here? So brokers are Kafka servers that manage the data storage. Okay, so here we have like couple of brokers, right? So we have a broker 1, broker 2, and broker 3. So Kafka cluster typically consists of multiple brokers to maintain the load balancer here. So Kafka brokers are stateless here, so they use Zookeeper for maintaining their cluster state. So here Kafka broker instance can handle hundreds of thousands of read and writes per second. Okay, so and each broker can handle terabytes of messages without any performance impact. So here we have a broker 1, broker 2, and broker 3. So each one will have a topic 1, okay, and partition 0 and partition. So we have like individual topics and individual partitions here, right? So each topic partitions having replica with like another broker here. So Kafka uses the replication to ensure the fault tolerance here, so and data durability. So if any broker goes down here, so each partition has one leader and multiple followers, right? So these leader and followers that distribute the same data across the multiple brokers. If any one of the broker goes down, so another broker will having the replica with this partition. So this is how this will handle like fault tolerance and data durability. And we have a Zookeeper. So here the Zookeeper acts as a distributed coordination service in Kafka. So Zookeeper is used to managing and coordinating Kafka broker. So Zookeeper service is mainly used to notify the producer and consumer about the presence of any new broker in the system or like failure of the broker in the Kafka system. Okay, so let's say that as per the notification received by the Zookeeper regarding the presence or like failure of the broker, then the producer, okay, and consumer takes a decision and starts coordinating their task with the some other broker here. Okay, so that's what I mentioned here. This is I mean like this will act as a distributed coordination service in Kafka, so that will facilitate tasks such as metadata management, leader election, consumer grouping coordination, and configuration management for maintaining reliable and efficient distributed streaming platform here. Okay, and this is the Kafka cluster ecosystem. Okay, Kafka ecosystem will look like this. So I will explain one by one here. Okay, so if you can observe here, so you must aware of this main terminology such as the topics, brokers, producer, consumers here. Okay, so this diagram will have like couple of terminologies here. Okay, so here the producer will sending the message to this topics here. So the topics again will contains the partitions. The partitions will have offsets to track the consumer group or consumers here, right? So once the producer will send the message to this topics, the topics will store the data inside this partitions, right? Now, so from here the Kafka brokers, okay, will take into this. Okay, brokers are simple system, so that is responsible for maintaining the published data here. Each broker may have a zero or more partitions per topic here. Okay, so each brokers will have a leader and follower here. Okay, so what it will do is basically if there are like n partitions in topic, then less than n brokers, each broker will have one or more partitions that will sharing among them. Okay, so from there, as I mentioned earlier, the Kafka brokers will have a replicas throughout this servers. Okay, so if any one of the broker, I mean server will goes down, other one will become like primary server here. Okay, and we have a consumer group. So this consumer group will have like more than one consumer. Okay, those this consumer read the data from the brokers. Consumers subscribe to one or more topics and consume published messages by pulling the data from the brokers here. Okay, and yeah, so here we have a zookeeper, right? So as I mentioned earlier, zookeeper is used to managing and coordinating the Kafka broker here. So zookeeper service is mainly used to notify the producer and consumer about the presence of any new broker in the Kafka system or like failure of the broker in the Kafka system. Okay, whatever that offset it has, right? So that will this consumer will have the offset values, right? So this offset values again it has to be update the offset values back to this zookeeper. Again, if Kafka has to know, so the offset values, this Kafka will get the offset values from this zookeeper. Okay, so this is how the Apache Kafka ecosystem will look like. And Apache Kafka 3.3. So in the latest versions there is no zookeeper. So Apache Kafka 3.3 replaces zookeeper with the new K-Raft consensus protocol. Okay, so this consensus protocol basically uh, yeah yeah, this is how this will look like. So that is Kafka raft, that will called as a K-Raft protocol. Okay, so Kafka raft metadata mode, sometimes referred as a K-Raft, so which is an alternative metadata mode, so that is introduced in Apache latest Kafka version to replace the dependency on Apache zookeeper cluster coordination and metadata management here. Okay, so the Kafka cluster, the current Kafka cluster will look like this. So each broker will have a quorum controller here. Okay, so there is no zookeeper here. So these quorum controllers will take care of this reading and writing the events to this metadata topic. There is a metadata topic, so that metadata topic will maintain this metadata inside this Kafka cluster. Okay, so yeah, this is the one more update in the current Kafka version. And Kafka use cases. So where you can use Kafka exactly? So to process the payments are like financial transactions in real time, right? Such as in stack exchanges or banks or insurances. Okay, and to track and monitor the ports and trucks, right, and shipments in real time, such as the logistics and the automotive industry. So we'll use this Kafka. And apart from this, to continuously capture and analyze the sensor data from IoT devices or like other equipment such as in factories and wine parks. we will use this Kafka. And apart from this, if you want to collect immediately react the customers interactions in e-commerce on order sites such as retail or hotel and travel industry, we will use this Kafka. And apart from this, in hospitals as well, right, to monitor the patients in hospital care and predict the changes in the condition to ensure the timely treatment in emergencies. And apart from this, if you want to connect, store and make available data produced by different divisions of company, okay. And but the last one is like to serve as the foundation for the data platforms, right? Event driven architectures and microservices also we will use Kafka here. Okay, so this is overall the Kafka. So now we will jump into this Kafka Spring Boot with Apache Kafka integration. To work with this Spring Boot with Kafka, so the prerequisite is we need to install this Kafka in our machine. Okay, so I have already installed this latest version in my system. Okay, so current version is like 3.6.1 that is installed on my machine. Okay, so which will support Kraft instead of Zookeeper. Okay, and so we need to run this Kafka on my machine, right? So to run this Kafka, so we need like couple of commands here. Okay, so if you are using like Kafka with Zookeeper, so this is the official documentation of this Kafka. You can just go through here. So if you are using Zookeeper, Kafka with Zookeeper, just use this commands. Otherwise, if you are using like Kafka with Kraft, you can use these commands. Okay, so first of all, we need to generate a cluster UUID. Okay, so the cluster UUID, so basically it will generate a unique cluster ID. So you will create a copy of unique um, identifier, so which is used in like Kraft to uniquely identify the brokers on the same clusters. Okay, and after that we need to format the log directories by using this UUID. So we need to paste UUID here. Okay, so this will format the log directories, and after that we need to start the Kafka server, okay, by using this command. So that's it, right? So it's very simple. So first of all we need to generate UUID here. Okay, let's go to terminal, let's hit this. Okay, it's generated UUID. Okay, and let's copy this and let's paste here. Okay, copy this command again. So come back to your terminal, let's hit this. Okay, so what it is saying that this is already formatted. So it is saying that it is already formatted, so you can ignore this. So the third command is, if you're running the first time, right, so it will format the log directories. Okay, and the third one is you need to start, okay, Kafka server by using this command. Okay, so it started successfully. So if you want to see like the details of this Kafka, so you can just go through here. Okay, and once it is started, we are good to use this Kafka in your local machine, right? So I need to talk more deeply about producer, so before I can move forward with the writing the producer program here. Okay, so here we have like producer. So these producers will send the data to this Kafka topics, right? So Kafka producers send the messages asynchronously here. Okay, before sending the message to this Kafka, producers serialize the data into a byte format. Why? Because this Kafka brokers will expect it into the byte format. Okay, that is the reason we have to be transform object or like message into a byte format before we are going to sending this event messages to this Kafka topics. Okay, and Kafka topics are divided into partitions. Okay, so you can see here we have a partition 1, 2 and 3 here, right? And producers can choose explicitly specify the partition to which message, okay, which message should be sent here. And apart from this, basically we have a Kafka message keys here. Each event message, okay, contains a optional key and a value. So in case if you are sending the key as a null, okay, I mean like if you are not sending key as specified by the producer, so the messages are distributed evenly across partitions in a Kafka topic here. So this means messages are sent a round robin fashion. So that is like partition um, 1, 2 and 3 as well. So if key, let's say that if you are specified key, I mean like if you are sending key as part of these messages that share the same key will always be sent and stored in the same Kafka partition. Let's say that if you are sending any key as 1, 2, 3 here, okay, so that same key will always be sent and stored in the same Kafka partition. So that will share to this Kafka partition 1 always. So, and apart from this, basically we have one more important setting, that is Kafka producers can configure acknowledgement settings. Okay, so as a shortcut we will call it as a axe. Okay, acknowledgement settings to control the durability and reliability of the message delivery. Okay, so let's say that while you are sending the messages, right, so Kafka producer can choose to receive acknowledgement of a data writes. Okay, so acknowledgement also known as a confirmation. So if you want the confirmation, then we need to use this axe. So we have three types of acknowledgements. One is axe equal to 0, uh, that is possible data loss, and acknowledgement equal to 1, that axe equal to 1. Okay, axe equal to 1. So let's talk about axe equal to 0. So in this case, the producer just sends the data that will not wait for any acknowledgement from this broker. Okay, so in this case, there is a possibility data loss, because if you send the data to your broker, okay, and the broker is down, so you don't know, okay, so what happened over there, so we did not get any confirmation. So in x equal to 0, so there possible data loss is there, and x equal to 1. So what is that x equal to 1? X equal to 1 means like, so by default Kafka 2.0 will make use this x equal to 1 here. Okay, and which the leader acknowledgement here. So leader acknowledgements here we have a Kafka brokers will have a one leader and two replicas, right? So if you can see here, the leader response requested here. So we have a producer here. So this producer will send the data to this, okay, data to this leader. Okay, and after that the leader says I got the data, and immediately it will send the response to this producer, right? So then what will happen is the producer know that the broker has the data, but if the leader goes down, let's say that if the leader goes down, okay, before the replicas uh, before the replicas have a chance to replicate the data. So we have two replicas, right? This data is not yet replicated to these two replicas, but if the leader is goes down, then there might be a data loss. So this is x equal to 0, so that is called as a limited data loss. And apart from this we have a x equal to all. Okay, so in this case, uh, x equal to all means basically saying that I want the replicas to be acknowledged here. So in the x equal to 1, basically the leader is provide the confirmation, right? So here the leader will take the acknowledgement from these two replicas as well. So in this case, so it will take the two replicas confirmation, then only it will send the acknowledgement or like response to this producer. So in this case there is no data loss. Okay, so now let's jump into this coding. Okay, so till now we have covered like theoretically, right? So now I'm going to explain about so how to create this Kafka producer and consumer. Okay, so we need like two things, right? One is producer, another one is consumer. So by using this producer, I will send the messages to that Kafka topic, right? So first let's create this Kafka producer. So I'm going to make use this Spring initializer. So here, so I'm going to choose the language as Java, and after that Marvin as a build tool. Okay, and so this is the version I'm going to use, that is 3.2.3 here. And let's take some group ID here. So let's take producer demo. Okay, and let's copy here and take artifact name same, And after that, so I'm going to take Java 17 version. So if you want, like, take current version, that is latest version. And after that, let's add some dependencies, that is Spring Web dependency. And after that, we need a Kafka dependency. Okay, and so let's take a Lombok for setters and getters, and let's generate this project and import into your IDE. Okay, I already imported this in my IntelliJ to save the time. Okay, let's create some configuration file here. Okay, so let's take configuration package. Inside this configuration package, I'm going to take producer configuration here. Okay, and so this is our configuration, right? So let's annotate with the configuration here. Okay, so here we need like couple of things. Okay, we need like three beans here. One is like producer factory. Okay, another one is Kafka template. Okay, and after that we need some new topic here. Okay, so first of all, like, I will discuss these three of them. So what is like producer factory here? So the producer factory is nothing but like it's a interface that is used to create Kafka producer instances. Okay, so by using this, basically the producer factory, developers can create and configure the Kafka producers in a consistent and flexible manner across the Spring Boot applications. Okay, so, and next one is Kafka template. What is a Kafka template? Kafka templates basically simplifies the usage of Kafka producers within Spring applications. I mean, like, by providing a higher level abstraction, right? So basically this Kafka template encapsulates common producer operations, such as like sending the message to the Kafka topics, and it will provide like couple of methods for like sending the messages synchronously as well as asynchronously. Okay, and after that we have a new topic. Okay, so new topic will create like some topic, so we have to send the messages on the topic, right? So this topic will work as a logical channel, so which will store the our messages. Okay, so first of all, let's create like producer factory. So as I discussed, we need a bean here, right? So okay, so producer factory, so I'm going to take string here. Okay, producer factory, and so here I need some map here. Okay, so inside this map I'm going to take string and object here. Okay, so let's create hash map, and after that, so this config maps will have some key and values. Okay, so we need like some values, keys and values here. The first one is we need like producer configuration. So we have a producer config class, so which will contains bootstrap server. Okay, so we have to provide like bootstrap configuration, that is local host, okay, 9092, and after that uh, we have to provide like, okay, key serializer class configuration. Okay, so string, okay, serializer class here, and after that we have like another one, that is value serializer class configuration. This is also string. So after that, let's return new default Kafka producer factory. Here we need to provide this configuration maps here. That's it. So our producer factory bean is ready. Now we need Kafka template bean here. Okay, so let's create this Kafka template bean as well. So this is also will take string and string here. Okay, so first of all, I'm going to explain about the only string, how to send the strings data, and after that I'm going to explain about customized object, I mean like user defined object. Okay, so here Kafka template. So this is simple, return new, okay, Kafka template. This will expect, okay, this producer factory here. That's it. And the last one is new topic. We have to create some topic, right? So let's create this topic bean as well. So I'm going to make use this new topic. Okay, so I will take payment topic as method name. Okay, and return new, okay, new topic. So this topic will have like three parameters. Okay, the first one is like number of partitions, sorry, first one is name, and after that number of partitions, and the third one is replication factor. So I'm going to take a payment topic as topic name, and after that three partitions, and I'm going to take one replication. Okay, replication factor is 1, so it is throwing the error. Okay, so replication factor is short here. Okay, let's take short. Okay, that's it. So our producer configuration is ready now. So we need a service, right? So that service will send the messages to the Kafka topic, right? So inside this service package, I'm going to create the producer service here. Okay, so let's maximize this and let's annotate with the service, right? So first of all, we need like a Kafka template. So we have to auto wire this Kafka template here, right? So this Kafka template, okay, so let's auto wire this. Okay, and after that, yeah, so what I'm going to do is here, so I'm going to generate some random transaction here. Okay, generate random transaction here, and after that I will send the transactions, I mean like payment transactions. So payment transactions, okay, in the two ways. One is like one is asynchronously, okay, and another one is synchronously. Okay, so okay, so first like generate the transactions, random transactions. Okay, so to do this I'm going to create one method. Okay, let's copy this same as method name, and here what I'm going to do is I'm going to take some vendors. Okay, um, so here I'm going to provide some vendors names here, that is Amazon, okay, and PayPal. Okay, let's take Visa, and after that MasterCard. Okay, after that I need a single vendor. Okay, so that single vendor, what I'm going to do is vendors. Okay, so we have like thread local random. Okay, I will make use this vendors dot length. Okay, so then I will get like single vendor here, and after that I need to send the amount as well, right? So let's take amount. So how do I get the amount? Here we have a thread local random, so current dot next double. So here you can define the range as well. Okay, suppose, okay, after that let's return vendor. Okay, so this vendor will have amount So amount I will take as a dollar here. If you want, like, take rupee as well. Okay, so that's it. Our generate random transaction is completed. So with the help of this Kafka template, I will send this payment transactions asynchronously. Okay, so okay, so public void, okay, send transactions, send payment transactions. Okay, you want, like, can use asynchronously as well. So here, so we need Kafka template, right? So this will send the transactions. So now, so the first one is we have to provide the topic name here. After that, so key and the value. So the value is generate the random transaction, right? So what I will do is transaction generate random transaction, right? So let's provide the transaction here, right? So that's it. And so here it will send it, right? So once it will send it, so what is the metadata? So I mean, like, where it has been sent it, like, so where it has been sent it to that specific topic, and what is the partition, and so what is the timestamp. So if you want to know those details, right, so we have, like, one asynchronous method. Okay, so with the help of that, we will, okay, we will get some information. So that is when complete method. So once it is send it, we will get some metadata. Okay, so which will contains, like, two things. One is, like, send result and throwable. Okay, so if this throwable, right, so this throwable not equal to null, right? So if it is not equal to null, then we can consider that, okay, so this is on failure. I mean, like, so this is failed. So I will pass this uh, throwable, okay, and I will create this method. Else what will happen, okay, on success, this send result, okay, we will create it two methods here. Okay, that's it. So now, so here I need to provide some metadata in the logs. Okay, so here we have, like, this send result, right? This send result will have some metadata, right? So this metadata I just printed here by using this send result, okay, object. So which will have, like, topic, partition, and offset, and the timestamp. So in the case of success, I'm printing all the information. In the case of failure, I'm just sending that, so error occurred while producing the message here. Okay, so that's it. And now, so this generating the payment transactions, right? So I need to run frequently for each and every 2 seconds, or like 2 milliseconds, right? So what I have to do is here I need to enable the scheduler here. Okay, enable the scheduling, and after that, okay, and come back to this method. So here I need to define the scheduler here. Okay, so some fixed rate is there, that is 2000 milliseconds here. Okay, so that's it. So every 2000 milliseconds it will send this payment transactions here. Okay, and log.info, here what I will do is um, sending payment transactions. Okay, and you can print the transactions here. Okay, that's it. So before this start this Kafka producer, you can just make sure that your Kafka cluster is open and running in your system. Okay, so let's hit this endpoint. So let's start this Kafka server and let's see whether it's working or not. Okay, so you can observe here so how this is sending the payment transactions. Okay, so this is sending the payment transactions, okay, visa amount like this, right? So this is randomly generating some amount for each and every 2 seconds here, right? So and after that I am receiving some metadata once it is sending to this Kafka topic. Okay, so I'm getting like topic name here, payment topic, and the partition 0 and offset. Okay, what is the offset and what is the timestamp, right? So like this I will get metadata here, right? And apart from this we have like offset explorer. So if you want to explore your I mean like this topic partition details, you can explore here. Okay, I connected here and let's refresh this. Okay, let's click on topics. Our topic name is payment topic. Let's click on this, and partitions, we have 3 partitions, right? And if you want to see here, we will see this, what is the start offset and end offset here. Okay, so if you refresh here, you will see all the details, and same thing we will see partition 1 and partition 2. We don't have any partitions information in partition 1 and partition 2. Okay, and if you want to see the data on partition 0, you can click on data and let's click on this play button. You will see data here. Okay, and replicas information also available. We have only one replica. Okay, this one, this is the node, right? So this is how the data will see here. And so we have 3 partitions, but the data is sending to the specific partition, right? So but what I need is I need to distribute all the messages to all the partitions. Okay, in that case I need a key here while sending these messages. Okay, I need to send the key as well. So what I will do is I will write one more method, public string, okay, generate transaction key here. So return, we have a UUID, random UUID toString. Okay, that's it. So let's make use this random UUID generation as a key in our, okay, Kafka template at send method. Okay, so let's restart this. Now if you can observe here, it is sending the message to all the partitions. First it started sending to the 0 and 2 and 0 and 1. Okay, like this, right? So in the offset explorer as well we can see here, so 0 is increasing this offset values, and let's see this one partition as well and second partition as well. Okay, so this is how the data will be distributed among all the partitions by using the key here. So if you're not providing the key, it will send to that specific partition, not for all the partitions here. Okay, so now let's stop this. So this is for like asynchronously sending the messages. What about like synchronous, right? So let's copy this method, okay, and let's paste here and change method name as synchronously. Okay, So we have a transaction here. Now I will remove this when complete. Okay, this is asynchronous, right? So I need synchronous. We have a get method. Okay, so this get method, okay, what is the error? Unhandled exception. Okay, add the exception to method signature. Okay, so this will return, okay, send result. Okay, so let's take the send result here, right? So so this is synchronous. Okay, now so this send result will have, okay, get record metadata, and this will have topic and offset and timestamp and partition, okay, all the details here. So we will print all the information here as well. Okay, so like this you can print it by using this send result here. Okay, so what I'm going to do is I'm going to return send result instead of void here. Okay, so now let's test this. Let's comment this asynchronous and let's enable on the synchronous method. Okay, let's start this application. Okay, so this is also sending the messages synchronously, and let's verify this offset explorer here. So we have provided the key, that is the reason it is distributing all the messages among all the partitions here. Okay, perfect. So this is how you can send your messages synchronously as well as asynchronously by using this Kafka template. So before I'm going to jump into this consumer programming, I would like to discuss about like consumer a little bit deeper here. Okay, so the consumer can read the data from one or more partitions at a time in a Apache Kafka here, right? So a consumer always read the data from lower offset to, okay, higher offset, but that is not possible in the reverse case. Okay, and if consumer consumes the data from more than one partition, right, so the message order is not guaranteed here across like multiple partitions. Why means like they are consuming simultaneously, right? So that is the reason it's not possible. So apart from this, the producers will send the data in asynchronous way, right? So the consumption also is asynchronous only. Okay, so that will allows the continuous processing without waiting for each message individually here. And after that, the producer will send the data in a serializable format. So whatever that data is coming to this serializable format, so the consumer also deserialize the data before it's processing here. Okay, so that will convert the byte format messages into usable data structures here. Okay, so apart from this, consumers are assigned to a specific partition, okay, within a topic that will enable the parallel processing and scalability. And consumers can acknowledge the message receipt and commit offsets here to the GPP, right? So that will ensure the reliable and at least once message delivery here. Okay, and apart from this consumer group here, right, so the consumers are organized into the groups, each processing a subset of the messages. Okay, and this facilitates the scalability and load distribution here. And apart from this, Kafka supports like mechanisms for like achieving exactly once semantics that will ensure the messaging processing integrity here. Okay. Okay. So now the producer part is done. So now we need a consumer, right? So let's take consumer demo here. Okay. Let's paste here and let's generate this project and import into your IDE. Okay. And I already imported here. So we need like one configuration class. Okay, let's create like configuration package. Inside this I'm going to create consumer configuration here, right? So this is the configuration, and so in this consumer configuration we need like two things here. Okay, the first one is consumer factory. Okay, and the second one is uh, concurrent concurrent Kafka, okay, listener, container, factory. Okay, so the consumer factory. So first of all, we need to create the consumer factory like we created. Okay, consumer factory here. Okay, here also string and string. So we are going to consume string here. Okay, let's maximize this. And so here also need a map of configuration, so that is string again and object here. Okay, and so let's import this map here. Okay, config map. Okay, and so let's create new hash map here. Okay, and config map dot put. So again here we need like consumer config, which will contains bootstrap servers configurations. So this bootstrap configurations, I need a local host 9092. Okay, and we need like key deserializer here. Okay, so key deserializer is string deserializer class. Okay, and I need one more, that is value deserializer class configuration. Okay, this is also string deserializer, and let's return. Okay, default consumer factory. This will take our configuration map. Okay, so our consumer factory bean is ready now, and after that, okay, we need this concurrent Kafka listener container factory. Okay, so this will also take string and string, and okay, let's import this. Okay, and what we have to do is we have to create the object for this. Okay, and we need to set this consumer factory here. Okay, and let's return this container factory here. Okay, so that's it. So this is our bean class. Okay, so our configuration class is ready. Now we need a service class. Okay, so consumer service. This consumer service, let's add it with at the rate of service here. Okay, we need a Kafka template here. Okay, private Kafka template. So let's take string. Okay, let's auto while, and so we need to consume the messages here, right? So public void, okay, listen the messages. So to listen the messages, what we need to do is, okay, so we need to listen the messages here, right? We need to have like one listener, that is Kafka listener. So this Kafka listener will have topics. So inside this topics we have to provide our payment topic name here. Okay, after that we have to define the group name here, group, that is group ID. Okay, so I just provided group ID, and after that you can provide listen or consume. So if you want like naming convention, you can provide the consume here. So here what I will do is I will take SL4J and I will print the log here, log.info. What I'm going to do is, okay, here string message here. So that's it, and you can just start this. Let's check it out. Let's start the producer as well. Let's see whether it's consuming the consumer here. Yeah, so we are receiving the messages here. Okay, so like this you can get the messages here, and let's stop this. So this is how you can consume the messages by using this Kafka listener here. Okay, so here we need to provide the topic name, here we need to provide the group ID. Okay, now we have seen like how to listen the messages here, okay, by using this Kafka listener. So here we are getting only string message, right? So let's say that if I want to see like what are the details are we required our end, so let's say that we need like partitions, offset details, and we need key and value, so all those stuff we required, right? So in that case, so what we need to do is we need to make use this consumer records, which will take the types here, that is key and value. So let's take type is string and value also string here, right? So here I will print like key and values, okay, that will get from this message, and partition and offset also I'm printing here. Okay, so let's check this. So first of all, like, let me start this producer, and producer is sending the messages, and let me open the consumer, and let's start this consumer as well. Now it should print key and value and partition and offset also. Okay, okay, you can see here we are getting partition and offset value. Apart from this, actually we are getting key and value as well, right? So like this it will work. Okay, let me stop this. Let me stop producer as well. So okay, so till now what we have covered is we have created the producers, and we have seen like how to send the messages with asynchronously as well as synchronously as well, right? And apart from this, actually we have sending the messages with key and without key, right? And we have created the consumer, and we have seen like how to listen the messages by using at the rate of Kafka listener as well. Okay, now the next one, so how to send the messages to a specific partitions. Okay, that means like how to send the message to specific partitions means we can specify the partitions, okay, specifically in our producer. So let's go back to our producer configuration here. Okay, and this is our producer service, right? So in the Kafka template we have a send method. So right now we are sending topic, okay, and key and value. So this send method, if you can see, this another send method which will contains partition as well. Okay, so topic, partition, key, and okay, data. Now let me go back to our method. Here I will specify partition 1. Now it has to be sent to only specific partition, that is partition 1 here. Okay, let's start this. Okay, so if you can observe here in the console, so it is sending to specific partition, that partition 1 here, right? And also if you want, like, you can check it out consumer as well. So it will listen the messages from the producer as well. Okay, you can check this latest messages we are getting only from partition 1, right? So now let's go back to producer and let's remove this specific partition value here. Okay, now how to listen the message from a specific partition, right? So let's go back to our consumer. The consumer, what we have to do is, this is our Kafka listener. Okay, so here we can define topic partitions. So under this topic partitions, actually we have a annotation called topic partition. Okay, so this topic partition, so okay, let's make it down. And here we have a like topic name. So in the topic name we can provide the topic. So our topic name is payment topic. Here let's provide here, and after that what we need to do is we have to provide the partitions. Okay, so the partitions you can provide like a number of partitions here. So let's say that I want to listen from only 0 comma 1. Okay, so then it will listen only messages from 0 comma 1. Otherwise if you want to listen from 1 comma 2, then you can listen only from this specific partitions. Okay, so if you want you can just test it out here. Let's start this producer and let's go back to consumer here. Okay, let's start this consumer. Now we can see only partitions from 1 comma 2 here. Okay, so if you can observe here, we are getting messages only from 1 and 2 partitions here. Okay, so this is how we can do it by using this configurations. Okay, let's stop this. Let's stop this producer as well. Okay, let's go back to our PPT. And so we have seen like how to send the message to specific partitions and how to listen the messages from a specific partitions. Now producing and consuming the custom messages. Okay, so let's open our code here. So I have already written this code for custom messages. Custom messages means in the real time. So let's say that if you want to send the objects data instead of string or like integer, like long values here, right? So here I have been taken as string as, okay, key, and value as location here. So location means this location will have a id and location. Okay, id and string here. So this will extend the message metadata in the real time. So we will send the messages metadata as well. So let's say that if I want to set the message id and source originator and timestamp. Source originator means like so from where this data is getting, like, let's say that you have like multiple services. So from you want to know, so from which service you are getting the this data. Okay, so this messages metadata is very important here. So that is the reason I just extended here. So along with this location data I will send this message metadata as well. Okay, and apart from this, while you are sending the messages, right, we need to serialize the data into the byte format, right? So here our key is string serializer and value is our JSON serializer here. Okay, this is very important. So you can just make sure that you can define this configuration here. And apart from this, coming to the producer service, so what I'm doing here is, so yeah, I'm just taking like some location data here in the form of array. Okay, New York, Los Angeles, Chicago, Houston, like this. Okay, and so okay, so here I am generating this random location data by using this thread local random. Okay, and I am making use here, I'm setting this data into this location object here. That's it. Okay, so I'm asynchronously only I'm sending the data. Okay, here, and this is the producer part. And coming to the consumer here, right? So consumer also same location data I'm using here. And if you go for this consumer configurations, here also we will have like group ID configuration. So group ID means for each consumer group there could be one unique group ID. So we have to define this unique group ID for your consumer group, which will contains like more than one consumer. So you can identify your consumer group with this group, okay, ID configuration here. And apart from this, we need to deserialize the data. So before we are going to consume our, okay, our data here. So our key deserializer is string deserializer and value deserializer is our JSON deserializer here. Okay, and the rest of the thing is same. Okay, let's go back to our consumer service. Okay, so here I'm just listening the messages by using this consumer record here. So let's go back to our producer service. Let's start this. Okay, now we are sending the messages to a topic and go back to our consumer, and let's start this consumer here. So this time actually I'm expecting key and value is our location data here. Okay, so this is my key and value. So if you can see here, key is there and value will contains message id, timestamp and id and location name here. Okay, and source originator, so that is location service. So like this we will get this key and value. Apart from this we are getting partition value and offset value here. Okay, so this is how we can send and consuming this custom messages here. Okay, so now one more thing is like consumer partition rebalance here. So rebalancing means, let's say that your consumer group has like more than one consumer, right? So in this case basically what will happen is um, group coordinator will come into the picture. So let's say that you have a multiple consumers, more than one consumer, like two consumers are there. So the group id is same for that consumer group and this consumers, right? In this case, so the group coordinator will trigger the rebalance here. So what is a rebalance? Rebalancing means changing the partnership ownership from one consumer to another consumer. Okay, so that rebalance will occur here and group coordinator will assign the partition to a specific consumers. Okay, so let's see that example as well. Now so here, so we already running this consumer, right? So in this case actually we have a three partitions. We have a single consumer and three partitions. So these three partitions are assigned to a single consumer. Okay, that partition is topic 0, 1 and 2 here. So three partitions are assigned to a single consumer here. Now so what I'm going to do is I'm going to start one more consumer here, that is consumer 2. Okay, so what we have to do is edit the configuration. I already created the consumer 2, so here you can just define like another port number, so that consumer will going to start on this port number. Okay, and just run this, and now the group coordinator will come to the picture and assign the partitions according to this consumers. We have two consumers, right? So this consumer 2 has only single partition, that is partition 2 here, right? And let's go back to our consumer 1. So this is also has been changed. Let me show that one as well. Okay, see this group coordinator again assigned these two partitions only. So earlier we have a single consumer, at that time three partitions assigned to that single consumer. Now we have a two consumers. In this case two partitions only assigned to a consumer 1, that is 0 and 1 partition is assigned to a consumer 1, whereas partition 2 is assigned to a consumer 2. So this is how this rebalance will occur. Okay, and after that we have a committing offsets. Okay, so what is a committing offset? So let's go back to our code here. So yeah, before that what I need to do is, let's stop this, stop all here. So in the application.properties, what I need to do is I need to start this application in the debug mode. Okay, yeah, so here committing offsets means what will happen. So whenever this producer is sending the message to this topic, right? Okay, so the consumer will consume this partitions data from this topic partitions here. Okay, so whenever this consumer will consume the messages, okay, it has to be send the acknowledgement to this broker. Okay, so this is committing the offsets, right? So this committing offsets by default Okay, batch. So batch means we have a different types of acknowledgement modes here. So let's go back to this Spring documentation here. So what it is saying is uh, several options are provided for committing offsets. If the enable auto commit consumer property is true, Kafka auto commits the offset according to its configurations. Okay, so if it is false, by default it will false here. Okay, let me start this. Okay, so enable auto commit is false. Okay, that's what it is saying. So if it is false, the container supports several acknowledgement mode settings, right? So we have a several acknowledgement settings. Okay, so the default acknowledgement mode is batch here. Okay, so starting with 2.3 is the framework sets enable auto commit to a false. So that's what we can see here. And so we have a consumer poll method, so that returns one or more consumer records. Okay, the message listener is called for each record here. So the following list describe the action taken by the container for each acknowledgement. So by default this is our setting. So act mode is batch here. What is act mode? So commit the offset when all records written by the poll that have been processed here. Okay, so let's say that we have a 100 records. Okay, so at a time like we received like 100 records. So after this all 100 records are processed, then only the commit will be happen. Okay, so let's say that if you are using record here, so for each and every record it will commit the offset. So that's what it is saying, commit the offset when the listener returns after processing the record here. Okay, and apart from this we have a different options, time, count. Okay, manually also you can, okay, committing your offset as well. Okay, depends on your requirement, you can use here. Manual immediate also is there. So let me go back here. Okay, and let me show this batch mode. So by default it is batch mode, right? So yeah, so initially you can see this, we got like how many records, 56 records from the from the producer. We got 56 records at a time. Now what it is doing is, first of all, like it is processing. Okay, and partition 1 and offset. So each offset it is processing here. Okay, for each record you can see this processing and offset values here. So after 56 records are processed, then only it will commit the offset here. So I will show you that log as well. Commit the offset log here. See, so we can see committing list here. So at offset 50 it is committing. Okay, after that we got like single record only, receive one record, and after that, after processing this single record, we are again committing here. So depends on the receiving the records, it will commit the offset here. So this is batch mode. So what if, like if I want to enable, okay, record mode, for each and every record it has to be commit the offset, right? So okay, so this one, so Spring Kafka listener act mode equal to record here. Now let's clear this console and let's start consumer again. Okay, so here we can go to initial stage. Initially we got how many records, 10 records, and it is processing single record, and after that committing immediately after single record is processed here, right? And again, okay, one more record processing and committing, processing, committing. Okay, so like this for each and every record it will process and commit immediately. Okay, so like this we have a couple of options. As I mentioned earlier, we have a time, count. Okay, so depends on the requirement, you can choose different options here. Okay, let's stop this and go back to producer and stop this. Okay, and go back to our PPT. Okay, so let's say that if you want to use like concurrent consumers here, so if your application is running on like cloud or like Kubernetes, then this option is not required, because let's say that your application is deployed on Kubernetes pods, on like multiple pods, right? So each one will treat as a, okay, single pod here and single instance of your application, right? I mean like that will run a single pod is a single container. Then if your application on multiple containers, then this option is not required here. Okay, so let's go back to our code. Let me show you that example as well. So in the meantime, what I'm going to do is, let's start this producer and go back to our consumer here, and let's clear this console. Okay, now go to your consumer service. Okay, here we have an option concurrency. Okay, so if you want to start your consumer on 3 containers, okay, so you can just provide the concurrency here. To improve the performance of your application, then you can go for concurrency here. Okay, so let's start this consumer and let me show you how this containers will start parallelly and consuming your messages here. Okay, and okay, so if you can see here, we have a different options here. We have a container 1 here, container 2 here. Okay, and let me show you container 0 as well. Container 0, okay, 0 1 and 2. So 3 containers are parallelly consuming your messages here. Okay, so like this you can make use this concurrency as well. Okay, so now I'm going to talk about how to handle these errors in the Kafka. Okay, um so I'm going to show you like how to implement the error handling in the Kafka consumers for our Spring Boot application here. Okay, so we have like 3 options. One is like blocking retry here. What is the blocking retry? So do retry when retriable exceptions occur during like consuming a message. Okay, so if a exception is occurs, right, so then it will block the next message. Okay, and the non-blocking retry in Kafka, so name itself we can non-block the retry in Kafka here. Okay, so send the messages to another retry topic here. It will create like a retry topic. Okay, okay, and it will send the message to that retry topic. So when the message exceeds the blocking retry max attempts limit here, so we can define the retry max attempts limit here. So if it is exceeds, then it will send the message to this non-blocking retry topic here. Okay, simple. Okay, the next one is dead letter topic and handler. What is this? So we have to send the message to this another dead letter topic here. Okay, so when the message exceeds non-blocking retry max attempts limit here. Okay, even if this retry non-blocking retry max attempts limit is exceeded, okay, then it will send the message to this dead letter topic here. Okay, so now let's go back to our producer and let's start this application. Okay, and after that go back to our consumer here. um, okay, so in the consumer basically we need to throw some of the exceptions, right? So what I'm going to do is I'm going to take integer dot parse int here. So here I'm going to take message dot value. Okay, so what it will do is it will throw the number format exception because I'm taking the string value here. Okay, so let's start this consumer. So this is blocking retry. So I'm going to show you how this blocking retry will throw the exceptions here. Okay, and it will block the next message here. So let's stop this and so go to your console and search with back off here. Okay, okay, so you can see this fixed off back set fixed off. Okay, fixed back off settings here. So if you can observe here, so the default behavior is, okay, so this is the default behavior of this default error handler here. So here we have like couple of fixed back off options. One is like so what it is saying is the default behavior is attempting to consuming the one message at least 10 times here. Okay, then the consume the next message and print the error log if it is like still fails. Okay, so uh, and after that it is sending some messages, right? So then it is printing the error here, number format exception here. Okay, so like this it will block to the next message here. Okay, next one is like non-blocking non-blocking retry here. Okay, so non-blocking retry, what we can do is here we have a at the rate of retryable topic here. Okay, so with the help of this it will build the retry topics for us with the like broker default settings here. Okay, so here what we can do is we can provide like sorry, inside this we can provide the attempts here. So how many times you need to be retry your message here once it is failed. And after that we have a backup. So within the backup we have at the rate of backup, so this will take some delay. Okay, so how much time you need to be take delay here, let's say that you need to take like 3000 milliseconds here, you can just provide here. And after that we need to provide the multiplier here. Okay, so initially it will take like 3000 millisecond. For next attempt how much time you need to be multiply. Okay, so let's say that I need to multiply two times here. Let's say that initially it will take 3000, for the next attempt it will take 3000 into 2 6000 milliseconds. Okay, like this it will retry and it will send the message to retryable topic here. Okay, how many times? Three times it will be attempt. And let's start this consumer, and here you can see all the messages. Okay, and stop this and go to your initial stage of the console. So here you can see we are getting the messages and it is sending to this retry topic here. Let me show you that. See this. Okay, destination resolve return the non-existence partition payment retry topic 3000. Okay, Kafka producer will determine partition to use for this topic. So if you want like in detail exception details, just go to this offset explorer and just reconnect here and let's click on this topics. Here we will find so this retry topics here. The first one is payment topic retry 3000 milliseconds, right? And after that we have like one more, that is second attempt like 6000 milliseconds. Okay, and if you want like check it out this partitions details as well. Okay, here we have properties as well, how many messages we got it, what is the offset values, and consumer also have this group IDs. Here also you can see so what is the topic and what is the partition and what is the starting offset and what is the ending offset and what is the lag here. Okay, so like this we can see the all the messages here. And now so we have a dead letter queue or like a dead letter topic as well. So what we need to do is if this attempts is exceeded, okay, if you want to send this failure message on the dead letter queue, what we can do is so we have to create one, okay, dead letter queue process messages. Okay, um, process failure messages. Okay, process failure messages. And here you can provide consumer record. So this consumer record will take both of the strings. Okay, and I'm going to take the message here, and here you can just print this key and value and just change this key and value. I'm going to print like dead letter, okay, topic key and value here. And on top of this method I'm going to provide the dead letter handler here. That's it. Okay, now let's start this and you can see the console how this dead letter handler will reach the message to this dead letter topic here. Okay, and let's stop this and let's go back to your console and let's see how this dead letter, okay, is receiving your messages after this three attempts is exceeded. Okay, here we can see we are getting dead letter queue, this is a record. Okay, and this is the message. So once three attempts is exceeded, okay, then the messages are reaching to this dead letter queue here. So if you want you can see here as well. Okay, dead letter topic key. Okay, like this it will print and go back to your offset explorer and let's reconnect this and go back to our topics here. We have a dead letter topic here, right, and partitions, and check it out. So here also we are getting the messages. This is okay, offset values, and here we have a group id as well. So let's click on this group id dlt, that is dead letter q. Okay, you can see this partition, and this is the starting offset and ending offset. Okay, so like this it will print all the messages once it is reached to dead letter queue here. So in the real time what we need to do is, once you got like failure messages on the dead letter queue, so you need to know, right, so how you are how to handle these messages. You need to send some emails, okay, email notifications here, okay, about failure messages here, so that like development team or like users know that so these are the messages are failure, so that like we need to take some action to resolve these messages. Okay, so like this we can handle the exception handling in the Kafka. Okay, so that's it guys. If you like my video, please go ahead and like my video. So if you haven't subscribed my YouTube channel, so please go ahead and subscribe my YouTube channel. Thanks for watching. Bye, have a good day.